Hey, welcome back. I've got another central impact problem here where we have bodies A and B colliding. The velocities are the same as the last example, but the masses are different now. We have 100 grams and 300 grams, and also this collision is going to be perfectly plastic. So that means that these two objects are going to stick together upon impact and not separate, and they're going to have the same common velocity afterwards because they're moving as one. And basically for that to happen, that means that our coefficient of restitution here has to be equal to 0. So let's write our equation for conservation of momentum, which in this case is going to be the mass of A times its initial velocity, VA1, plus the mass of B times its initial velocity, VB1. That is the total momentum of our system before impact. And after impact, because the objects are going to stick together, we have to add those two masses together, MA plus MB, because we've essentially created one object with a single velocity of V. So the point of this problem is to find what is the final velocity of these objects after the impact. So let's fill out the information that we have. We know that the mass of A is 100 grams, so that's 0.1 kilograms. The velocity is 1.5 meters per second, plus the mass of B, 300 grams, so that's 0.3 kilograms, times the velocity of B, it's negative 0.8 meters per second. And again, that's because we're defining the right as the positive direction. And this is going to be equal to MA plus MB, so that's 400 grams, so that is just 0.4 kilograms times that final velocity of the combined object. All right, we can simplify this a little bit. We're just going to have 0.15 kilogram meters per second minus 0.24 kilogram meters per second is equal to 0.4 kilograms times that velocity. So the left-hand side simplifies to negative 0.09 kilogram meters per second, and the right side stays unchanged. Now before we go any further, it is important to mention that kilogram meters per second is the units of impulse, and it's the units of momentum. What we found here on the left-hand side is the actual momentum of the system. It is 0.09 kilogram meters per second to the left. That's what that negative sign indicates. So afterwards, after we find the final velocity, we're going to check to make sure that our momentum after equals this as well, but just look out for that too. So if we just divide 0.4 kilograms from each side, we have negative 0.09 kilogram meters per second all over 0.4 kilograms, and that is going to give us the final velocity, which is equal to negative 0.225 meters per second. That negative sign indicates that it is going to the left. So if you were just asked to find the velocity after the impact, then you are done. You can put a box around the answer. That is the combined velocity for A and B together. They're moving as one object. But if you have time, I really recommend that you check that you've got the right momentum for after impact. So that is the mass of the combined object after times its velocity, so m times v, which is equal to 0.4 kilograms times its velocity of negative 0.225, running out of space, meters per second. 0.4 times negative 0.225 also gives us negative 0.09 kilogram meters per second, which is good. That is what we expect because that's what we also calculated for momentum before the impact, and this confirms that momentum before is indeed equal to momentum after. So if you have time, always on a test or something, do this check. It's worth it because you'll find out if you have an error and you can quickly go back and fix it. And I also just want to demonstrate one thing here. It's kind of extra, might not have anything to do with the problem that you're asked for, but when we have a perfectly plastic collision, the maximum amount of energy is lost. So we can check the kinetic energy of our system before impact and the kinetic energy of the system after impact and compare them to see how much energy has been lost. So we can just write here the kinetic energy of A and B before impact, and then we can check the kinetic energy after impact of A and B moving together with that velocity that we calculated. And here actually for before, we need to sum these. I've put a negative sign here. It actually computes as a positive, but because we know it's going to the left, they're going to net out to a value that is one going positive and one going negative. So the sum is just 0.0165 which is 0.386, so you can round that to 39. So we've actually lost 39% of the kinetic energy in this plastic collision. So momentum is conserved completely, and for a perfectly plastic collision, the maximum amount of energy is lost.